Exercise 8.4, problem 16 to 20. The total surface area of a solid hemisphere whose radius is a units is equal to, okay, they have given us 4 options. So now let's say the TSA of this hemisphere is 3 pi r squared. Am I right? So here they have given us the radius as a units. So basically we need to substitute r as a. So this will become 3 pi into a. So you'll get 3 pi a square. 3 pi a square is basically option B, right? Next problem, 17. If the surface area of the sphere is 100 pi centimeter cube, then its radius is equal to, they have given us few options. So again, the surface area of a hemisphere is 4 pi r squared. So equate that to 100 and find the radius from that equation. Surface area of the sphere is 4 pi r square. In this case, it is given as 100 pi. So 100 pi will be 4 pi r square. Now you can cancel all few of these things. Pi and pi will cancel. So 4 will go 25 times. So r square will become 25 and r will be equal to 5 centimeter. And that is option C. Right? Now let's go to 18th problem. If the surface area of the sphere is 36 pi centimeter square, the volume of the sphere, this is very simple. Earlier we did calculated radius. So once you know the radius, you can calculate the volume of the sphere, right? So CSA of the sphere is 4 pi r square and that is given as 36 pi centimeter square. Equate it. So now what will happen? This pi and pi will cancel. Okay. 4 will go in 36 9 times. So r square will become 9. R square equal to 9. So r will be equal to 3. So now you know r equal to 3. What is the volume of the sphere? 4 by 3 pi r cubed. So it will be 4 by 3 pi into 3 cube. 3 will cancel this. So it will become 3 square. That is 9. So 9 into 4 is 36. So it will be 36 pi centimeter cube. So that is basically option B. So instead of giving the radius directly, they have given the radius in terms of curved surface area. So from the curved surface area, you are finding the radius and then using that radius to calculate the volume of the sphere. Okay. Right. Problem 19. If the total surface area of the solid hemisphere is 12 pi centimeter square, then the curved surface area equal to. So total surface area is 3 pi r square. And curved surface area is 2 pi r square. Okay. So from this you can calculate radius and use that radius to find the curved surface area, or you can find the r square and use that r square here. Let's see how I've done. The total surface area is 3 pi r square. So that is 12 pi centimeter square. So what will you do? So this pi and pi will cancel. Okay. So 3r square will be 12 or r square will be 12 by 3, that is 4. Now the curved surface area is 2 pi r square. So that r square you can straight away substitute. So that is why I am not finding r and then recalculating r square. Okay, I am using the r square directly here. So that will be 2 pi into r square. R square is 4. So if I put that here, so 4 to say 8. So you will get 8 pi centimeter square. So that is option D. Okay. Now, next problem, 20th. The radius of the sphere is half the radius of another sphere, then the respective volumes are. So, let's take the first radius of the first sphere as r, and then the next sphere will be 2r because it is twice, or the first one is half. So, the radius, let the radius of the spheres be r and 2r. So, this is the first sphere is half of the second sphere. And what is the volume of the sphere? 4 by 3 pi r cubed. So, V1 by V2 will be 4 by 3 pi into radius of the small sphere, that is r cubed, divided by V2 4 by 3 pi and the radius of the second sphere. Radius of the second sphere is 2r. So, it will be 2r cubed. Am I right? So, now you can cancel this 4 by 3 and pi also can be cancelled. So, this will be r cubed by 2r, the whole cubed is 8r cubed. So, this 8r cubed and r cubed will cancel. You will be left with 1 by 8. Therefore, V1 to V2 is to V2 is 1 is to 8. Okay, so the key is assuming the radius of the first sphere to be r and the second sphere to be 2r, and use those values here in this formula and simplify it to get the final ratio. So which option is this? 1:8. That is option A. See, they have given us 8:1 also. So that is why you have to be very careful here. So I am writing it, the first sphere is r and the second sphere is 2r. So this is V1 and this will correspond to V2. And we have found V1 by V2. So that is why it is 1 by 8. Okay, if I have to find V2 by V1, it will become 8:1. So I have found it as V1 by V2 and it's come out as 1:8. So this ratio, the correspondence must be correct. Okay, correspondingly, so this R corresponds to V1 and 2R corresponds to V2. So we are finding V1 by V2 and that is why it is 1:8. Okay. So I hope these problems are clear. If not, please go through one more time. It will become clear. Thanks for watching this video.